Hello and welcome to challenge 4 of 150 Python challenges that I'm going through from this book by Nichola Lacey, Python by Example. Really good book. I'd recommend you check it out if you are thinking about getting into Python. It's got some lovely examples and like everything's there to like support you in solving the challenges. It's really cool. I'm going to be solving the challenges, but I'm doing it 3 ways. And today we have this challenge. This is number 4. We're still in the basics. So it's still pretty straightforward, still pretty easy. So ask the user to enter 2 numbers, add them together and display the answer as the total is answer. Okay, so beginner, we need 2 numbers. So we're going to print, please, actually we're just going to use an input. We're going to say num1 equals input. Please enter a number. Going to copy that, we're going to paste it down here. We're going to say num2 equals input, please enter a number. And then we're going to print a format string that says the total is, and then we're going to put num1 add num2. Okay, let's give this a go. Please enter a number. Let's just do 2 add 2. 2, 2. The total is 22. Now, when we use input, we get the input in as a string. And when you add 2 strings together, you just join them. So it's joined the 2 with the 2 and got 2, 2. Okay, so we haven't actually performed maths on these. So what we need to do is cast this to an integer. So I'm going to wrap input within int, like so. Okay, and now we're going to try again, please, and let's clear this, and let's try again. So please enter a number 2, and I'll do 3, just to change this up. 2 add 3 is 5, the total is 5, perfect. And you can see we've got no code for medium, no code for advanced, because we haven't filled in those functions yet. So, challenge solved, that's beginner level, easy. Next, we have medium level, and in the medium section, I want to think about how we get our user input. So I'm going to create a class called user input. Why not? Like, I could have called it anything, could have called it donkey, but I've called it user input. And we're going to define a method on the user input class called get number. And we're going to have an optional, let's say get integer, just to be really clear. Okay. And we are going to put self in there, and we are going to essentially do something similar to this, but we're going to do a few checks. Okay. So first of all, this is going to return us a, this is going to return an integer, and we are going to allow the user to give their own message. Okay, so we are going to say a message and maybe a label. And so what we're going to do is we're going to print message, and then we're going to say like response equals input, and then we're going to put in a format string of label, and we are going to no, that's fine, yeah, colon space, and we're actually going to give this a default value of number. So oh, no colon needed. So if they don't have to supply number, and they can just give a message. Cool, so that's our response, and then we are going to ensure that that is a valid integer. So what we're going to do is we're going to try to convert our response. So we're going to say int, we're going to say number, yeah, we haven't used the word number yet, number equals int response. Okay, if we can't do this, if this throws an error, so if I come down here in a terminal and go into Python, the Python interpreter, I can say something like a equals hello, and then we can try and convert a to an integer, and we'll get a value error. So it will say, no, you can't do this because hello can't be converted into a number, which is fair enough. But if we try to do something, when that error gets raised, we can actually catch it using the except statement. And then we can think about what we're going to do here. Okay. So what we're going to do is we're going to try number equals in, and then we're going to return number. Okay. Except is going to print invalid integer. Please enter a whole number. And then what we're going to do is we are going to wrap this in a while loop. In fact, actually what we're going to do is we're going to say valid response equals false, while not valid response. We're going to chuck all of this inside that while loop. So we're going to get our response, we're going to try and convert it. If we do convert it, then we're going to say valid response equals true. Otherwise, we're going to print invalid integer, please enter a whole number. And then right at the end, we are going to return number. Okay, so this gets us an integer, and it also gives the user, if they mistype, it gives them a chance to like actually put the number in. So let's see if this is working. We're going to say user input equals user input, and then we're going to say user input dot get integer. The message is going to be please enter a number. I think that was what was in the thing. Just ask them to enter two numbers. Cool. Please enter a number, and we're going to store that as number. Cool. And let's just see that. Let's just check that loop is working. So I'm going to exit out of the Python interpreter. I'm going to clear my terminal, and okay. So beginner, please enter a number. 1 1. We get 2. Medium, please enter a number. Right. I'm going to pop in Bob. Invalid integer, please enter a whole number. So this is working. So now we've got some actual checking going on. So if I say hello, oh, I didn't even spell hello right. Hello. Okay, it didn't work. But if I put in the number 43, bang, it's happy, and it lets us out of that loop. So we can see that working. Okay. Also worth just thinking about is the fact that if we entered hello here, that would break, right? So the first one, the beginner one, will break easily. Our medium one is actually a little bit more sensible and won't break if we add in an invalid number. It will be like, oh, try again. So we've got our get integer function. So now we can get our number 1. Please enter a number. And then we're going to say something like, please enter a second number. And that is going to be number 2. And then we are going to print. And we're going to just print out the statement here. The total is num1 add num2. Although I called it number 1 in this because number is well, it's an actual word, so that's helpful. And let's give this a go. So if we cancel out of that, clear that, give this a go. So beginner, 1 and 1 gives us 2. Medium, 13 add 3 should give us 16. Bang, lovely stuff. And let's just try that again, but let's try, so 1 and 1. Let's try this time. We put in hello, doesn't work. We put in the number 5. Then we put in Bob, Egg, Steve, and then we put in the number 1, and then we should get the answer 6. 5 add 6. There we go, the total is 6. So it's ignoring all of these weird things that we're putting in, and it's just getting the numbers out. Okay. Lovely stuff. So, on to advanced. Now, what I want to do is I want to try and like encapsulate all of this so that we can have something a bit more coherent, a bit more structured. So we are going to make a class called a calculation. And that is going to be an abstract base class. We're going to import that ABC abstract base class. And it is going to have a method called calculate. And it's going to take two numbers. It's going to take number 1, which will be of, I guess it should really be a float, and number 2. A float is a decimal point number. Kind of just makes sense. Oh, number 2. And it's going to return a float. Okay. And we are going to raise a not implemented error here. And this is an abstract method. So this is a base class, and this is essentially saying anything that is a calculation should have a method called calculate, which takes two numbers and returns some other number. But if you haven't made this method, then we're going to throw an error when it comes to doing it. So now what we're going to do is we're going to make a class called an adder, and that is going to be a calculation. So it needs a calculate method, and you can see there it's auto completed it for me because it knows that this is an abstract method, so it has to inherit this. So it's put that all in for me. I don't want to return this, however. For an adder, I want to return number 1, add number 2. Cool. So we're going to use this idea, but we're going to do it slightly differently. So we're going to make a class called a number pair, and we're going to have two properties on it. We're going to have number 1, which will be a float, and we're going to have number 2. I keep forgetting, which will also be a float. We do need. No, we don't. No, we don't. I guess actually. Yeah, and we'll set those both to 0 to start. And what we're going to do is we are going to say this number pair is going to have a method called from user input. And that is going to take a user input object, which we made earlier. And this is going to be a no, it's not. I guess it is. This is going to be a data class. So we're going to make this, from data classes, import data class, which means that we're not going to use self, we're going to use CLS, and we're going to call this a class method. At class method, lovely stuff. And what we're going to do is we are going to essentially use this logic from up here. And what we're going to do is we're going to get number 1. We're going to say, please enter the first number. Please enter the second number. Then we're going to return a instance of class where number 1 is equal to number 1 and number 2 is equal to number 2. Cool. Let's put it all together. So, first things first, we're going to get our user input. So we are going to say number pair equals number pair dot from user input. And we need a user input for this. So we're going to say user input equals a user input, which we created. We're going to say user input equals user input. Ah! Cool, so that's got our number pair. Then we're going to need ourselves an adder. So we are going to say adder equals adder. And we need to give it, we don't need to give it anything actually, because we're going to say adder dot calculate. And this expects two numbers. But actually, we now have this nice data class to encapsulate a number pair. So what we're actually going to do is we're going to get rid of this in the abstract method. I'm going to call this a number pair, and it's going to be of type number pair. It doesn't know what this is because it's defined down here. So if I just close this up a little bit, because number pair is below calculation, the Python interpreter's not read number pair while it's reading calculation. So it's like, what is number pair? So to fix this, we're going to come up here, we're going to say from future import annotations, and that will just work. It will be fine. So if I scroll back down, now number pair is happy. Okay. In a later version of Python, that won't be a thing, but we have to be a bit considerate of that for now. And the adder also needs to be updated for this, so we're going to take that. Going to take that, and now what we're going to say is we're going to say number pair dot number one, add number pair dot number two. Okay, so we've got ourselves a calculation, which is an, I guess we should actually call this an addition. F2 on your keyboard will let you rename something, and it will rename it everywhere that occurs in your code. So it's like a really good way to rename things and a good habit to get into. Incidentally, is also the key that was mapped to the stop recording button while I've been doing these videos, which led to a lot of head scratching for me as to why do they keep stopping and having to redo. But F2 is your friend, so you can see it's changed here, addition. It's also changed here just from one rename, which is really handy. So got ourselves an addition. Now we can calculate with a number pair, and now we just need to display that. So what we're going to do is we're going to let's make a data class called a let's say class calculation result, and that is going to have the result, which will be a float, and it is going to have a method called display, which will print out what we need to print out. The total is, and we are going to print out self.result. So then here in our calculation, instead of returning a float, we're going to return a calculation result. Same with the addition. And last but not least, instead of returning this, we are going to say calculation result, where the result equals, this is getting a bit long. Let's do result equals that calculation, then result equals result. I'm going to rename this to addition result, just so I realize that I'm doubling up on the variable names a lot and it's getting a little confusing. Result equals addition result. So then we got ourselves a calculation result. So then here, when we say result equals adder.calculate, we can then say result.display. Okay, so here's our advanced. We've got a user input. We get a number pair from user input. In fact, one thing I can do, because I don't need to add anything into this, I can just new this up here and get rid of this first line. Just makes things a bit tidier. Okay, so we got ourselves a number pair. We then get ourselves an addition, and we use that addition to calculate our number pair, and then we display our result. Let's give it a go. I'm not happy with how the terminal looks. There we go. Okay, so beginner. 1, add 1, 2. Medium. 2, add 2, 4. Advanced. We haven't actually tested any of this yet. So 3, second number 3, the total is 6. There we go. And that is it. We have managed to use some different classes, model our data. We've modeled our behavior. And so we've got calculation, we've got addition, which is a type of calculation. We've got a number pair, we've got a calculation result. And so all of our data is really nicely structured here. Now, if we decided that actually we didn't want to, oh, and we've also got the user input up here as well, which is nice. If we decided that we didn't want our calculation result to be a float, we want it to be an integer, we could change that behind the scenes in the classes and how they work, but it wouldn't actually change any of this code here. Okay, so the actual code, the logic, the structure of our program here wouldn't need to change, because all this is doing is just saying like the operations that we want to perform, and the actual mechanics of how that work is abstracted away. And so we can just change that underlying implementation and not have to worry about the code structure itself, which makes for a more advanced programming style. This has been Challenge 4. Thank you very much for watching. All my solutions will be on GitHub if you want to check them out. And I'll see you in Challenge 5.